So let's go back. We're going to talk about the actual, ISO 62440 series of standards. And I say series of standards because it's a big book. I believe it's around 900 pages. What we're showing on the screen here now. It's separated in four categories. The 62443-1 is basically mostly general information, concept and models, a glossary, life cycle metrics. It's very generic, very informational. Is 62443-1. Now, 62443-2 is basically focused at asset owners. So the company that actually, the manufacturing company that actually has this system running, he is considered the asset owner. Um, there's a number of technical requirements there. There's only one formally adopted piece of the standard, which defines the cybersecurity management system, or CSMS. You'll notice that that is very comparable in terminology, but also in context as the ISMS as we know it in ISO 27001. And you should really see them in the same way. The cybersecurity management system is the name that ISO 62443 gives to their management system. It's very similar in content and processes as 27001 ISMS, but of course it has a pure focus on industrial components. Now, the third part of the standard is oriented at system integrators. So the 62443-3 is fully focused at the system integrator. However, it's not always that black and white in real life, because an asset owner will often do part of the system integrator's work and vice versa. So assuming you have a clear separation between whoever owns the asset and the person or the company that designs it, it's very clear there. But that line is not always so obvious. And then 62443-4 is purely targeted at product manufacturers. It has two published standards, one for lifecycle management, one for technical security. I've took the liberty of adding to the EU flags there, but I think it's interesting. So the Cyber Resilience Act will mostly apply to product manufacture. This is a product standard that sets security requirements for products, while the NIS2 directive will, well, mostly apply to the asset owner. He's the owner and final responsible of the system. But of course, I mean, the system integrator will be closely related to what the NIS2, because the asset owner will have that as a requirement. Um, the ISO 62443 standards can and it should be used, both top down as bottom up. So the way it works is that top down, you have requirements that are being sent from the asset owner to the system integrator to the actual products you buy. But the other way around is that the product manager will manufacture products that are certified for solutions that the system integrator uses and for the solutions that are required by the asset owner. So it's a two-way street of both requirements top down and solutions from the bottom up. Now let's start the real difficult work. So we've talked about the Purdue model. We've talked briefly about zone and conduits in the introduction. So the next concept that I would like to introduce is the foundational requirements. Foundational requirements are basically seven core principles that apply to any and each of the different components of an industrial control system. Foundational requirement one, identification and authentication, is focused on obviously authenticating users, but the word user means either human, process, or machine to machine. So a user is not necessarily a person. Foundational requirement two is about ensuring that these users have the privileges to do what they need to do. One and two together, foundational requirement one and two together, are typically what in IT is called the IEEE: identification, authentication, authorization, accountability. Foundational requirement three, system integrity, is about the integrity of the system, integrity of the data, integrity of the communication, the storage, and it mostly addresses unauthorized, unwanted, unmanaged changes to systems. 4 is about data confidentiality. It's different controls that ensure that the information flowing through your industrial control system is protected. 5, restricted data flow, is what we would typically call segmentation and isolation. So it's about making sure that data only flows where you want it to be able to talk to. Foundational requirement 6 talks about monitoring, reporting security incidents, and managing the response to these incidents. So that's typically where you'll find incident management, but also disaster recovery, business continuity. And foundational requirement 7 is about resource availability, something that in IT we don't worry too much about, but is fairly critical in industrial systems. So this will ensure that systems remain available. Why am I focusing on these? Because these 7 foundational requirements will constantly be coming back in securing industrial control systems, and they are all one-on-one mapped against a number of technical, organizational, or process requirements. Um, Foundational requirements do not just stand on their own, they're used in combination with something called security levels to define the protection required for your system. Security levels is the next thing I will be talking about. Security levels are a somewhat strange concept, but the more you use it, I think the more you love it. There's 5 different security levels. Security level 0, which is not in this chart, just means that there are no specific requirements. And then from security level 1 to 4, it becomes more and more complex in means and resource and skills of motivation of the attacker of your ICS system. It's very
Sam, can this be considered as a maturity setting, or is it a requirement to get to this level? Is it rather a technical requirement?
Maturity is addressed separately in the standard. I'm not mentioning it in this introduction because it's only introduction, but this is purely about what threats do we want to protect us from, and then what technical and organizational measures will we take to do that. Um, Now, it's important that security levels are not just something that are gut feeling or experience based. The definition of a security level is always and only the result of a proper risk analysis. And I'll try and go into that a little bit more because the security level is important. Not only do we have 5, or let's say 4, because 0 is really a non-existent level, 4 security levels, we have 3 different types of security levels, and that's actually a very, very nice concept. The product manufacturer, the one down here, he will create a product. It can be hardware, it can be software, it can be a combination of both, and he will certify his products against a security level capability. So he will formally audit it and certify it, or he can even self-certify it if he doesn't want to go to the formal process. He will say the product that I offer is capable of doing security level 1, 2, 3, or 4. Now, we, the asset owners, we will also define a target security level. This is what we expect from the system to do once it's operational. That is the security level that we require based on our risk analysis. The system integrator, the person that configures your system, he will actually implement a system that meets or should meet the requirements of your asset owner, the target security level, and he will be doing that using products that are capable of meeting these requirements, of these requirements. So the security level capability is actually a very interesting way in where you can verify that whatever you buy is capable of doing what you require, or if for a reason of a product not being available or not existing in security level required, you know that your system integrator will have to take additional measures to compensate for that device not being capable of doing what you ask. Um, And I really like this concept because every OT vendor knows these security levels. You can just go to them and say, hey, I need this system and this is my security level. Um, Now, one thing I want to point out with especially the security levels here, if as an IT guy you will look at this, um, y- you will, I mean, you'll always be looking at, security level 3 or 4. It's easy. I mean, we want to, of course, we want to protect us. This is what we've been doing in IT all along. I think the reality is that, achieving a security level 2 in an industrial control system is a huge deal. Getting to a system that has security level 3 or 4, I think is simply not feasible today, or will be extremely complex, extremely expensive, very difficult to achieve. That's also why where these foundational requirements come in. Um, These security levels are not just one number for the entirety of your industrial control system. More often than not, you will do a risk analysis, and that risk analysis will define specific needs for specific foundational requirements. So if you look at this example here, we as asset owner have set a security level targets, and our risk analysis has defined that identification and authentication is important to us. Use control is important to us. System integrity, not so much. We're not interested. We just want to produce things. The quality of that is secondary for this installation. Same thing for data confidentiality. I mean, yes, there's a recipe in there on how we make our product, but honestly, any engineer can probably just do an analysis and get our recipe. So we don't really care about that. Segmentation, restricted data flow, and resource availability is very important to us. So rather than saying that we will install a system at security level 1, 2, or 3, we will define, if that's required, security levels for an individual foundational requirement. So you can actually, I said earlier that I don't think that a security level 3 or 4 is realistic today, but it is probably realistic to have, a security level 3 on some specific foundational requirements. Um, Now, in addition to the Purdue model, there's a concept called zones and conduits. Zones and conduits were introduced in the ISO 62443 standard as a way to segment and isolate various devices in the control system. So it's basically, for me, it's a grouping of systems that should be able to talk to each other. So it's in the IT world, it's very similar to what we do with segmentation, with the only difference that we also focused on how we interact between these zones. And that is something that in IT is often less important because we have this central firewall that basically also routes and take care of all the security. In the OT world, you'll find an ADSL somewhere, you'll find a 4G modem somewhere, you'll find a system that's managed by a vendor somewhere. So it's very equally important to look at how these things are connected with each other and not just look at the actual zone, or in the IT world, I would call segments.